Hello everyone. I think we have something new here. What is this? We have here Philips LED 7.5 watts and it is warm white, 15 years last at 2 dimmable. Oh, what is this? This is a lamp. Classic design made by Philips. Where is that? Here. This is the new lamp. Some sort of a filament here. Filament. And it is made up of LED. That yellow one. The orange one. And transparent. Classic design. It looks like an Edison, Thomas Edison bulb. It looks like. So, put it in the socket. Let us put it here. And we have now a new circuit here. This is a bulb, electric socket. This one is a switch. And this is voltage supply. Connected to the switch. 220 volts. Power source. Connected to my outlet. Yeah. And the other circuit is this. What is this? Resistor, LED, and the power supply of this. That's a transformer. But not a bumblebee. It's a transformer. Power supply. 12 volts. Converting the 220 volts to 10 volts. What is this? 220 volts. Here is the 220 volts circuit. This is 220 volts and this is 12 volts. What's the difference between the two? Let's see the circuit diagram. So, the circuit of this is this. LED circuit. We have the 12 volts, power supply, voltage supply, a switch, single pole, single throw, resistor, and an LED. And this is the circuit diagram. And this is our previous circuit. And we calculated the value of resistor here to protect the LED from burning. And we know that. And since this is our previous circuit, we calculated the values here. Just a quick review. And we have a layout here. The current flows here is from voltage supply when you close the switch to the resistor to the LED and back to the negative, to the ground. That is the current flows here. With the use of this 12 volt transformer, Optimus Prime. No, just a simple transformer. 12 volts. And here, we have here an electric bulb. It looks like the first electric bulb invented by Thomas Edison. I don't believe that Thomas Edison invented the first electric bulb. But I do believe that Thomas Edison is the first one who patented this electric bulb. So, in short, he is the one who invented the electric bulb. Because he is the one who patented this electric bulb. He filed a patent for this type, just like this type of bulb, the first electric bulb. So there's so many inventors of electric bulb, or electric lamp, or electric light. But Thomas Edison, I believe, is the inventor of this, because he is the first one who patented this bulb. So, in history, Thomas Edison is the inventor of electric bulb. As short as that. Let us see. That is the switch. That is the 220 volts power supply. This is a regular 220 volts you see in your house. 220 volts connected to my 220 volts socket there, somewhere there. And so what is the circuit here? This is now 220 volts AC. What is this AC? It's alternating current. Oh, 60 Hertz. That is the supply voltage from our electric company. They provide us this. What is this? 60 Hertz, 220 volts AC, alternating current. And here, that is the symbol. There's a switch. There is a light here, or the lamp. Let us see the given here. So, the lamp is 220 volts. And its power rating is 7.5 watt. So, this is 7.5 watts. It's made up of, the filament here is no longer a tungsten. Just like Thomas Edison's first electric bulb, it's made up of LED, sort of an LED. That is the new technology by the Philips. And you cannot copy this technology. It is illegal. If you copy this, since the Philips has its own brand, has its own technology, that is the technology of Philips. So this is the circuit diagram. Where is the current here? Let's trace the current here. So since this is 220 volts alternating, it means it flows back and forth. Just like this. Up, down, alternates. So the current flows when you close the switch to the lamp, making the lamp lighted, flows back to the ground. And since this is alternating current, also there is a reverse current flow from negative to the lamp when you close the switch and back to here. That is an alternating current. So let us compute the current here. Since we have given here the voltage supply, power supply, power rating, PV, power of the bulb. And here is the power formula. P, power, is equal to voltage times the current. And power is measured in a unit called watt. And voltage in volts. Current, I, in A, ampere. These are three scientists who discovered this situation, these things. That is the three scientists responsible for the discovery of this formula. So we get now I is equal to P over B. Substituting the value given in the lamp, we get now current of 0.03 ampere. That is the current flows in this circuit. But remember, this is an AC circuit. So we got here. This is again Ohm's law. What is this? Voltage is equal to current times resistance. Transposition method, we get now B over I. Substitution method, we get 220 over 0.02 ampere. Voltage supply here is 220 volts. So we got now a resistance of 11,000 ohms or 11 kilo ohms. And the unit for voltage is volts. And the current is ampere. And here is ohms. Ohms is also a scientist. A scientist, Alexander Volts. And this one, ampere, is also a scientist. And this ohms is scientist. These three scientists are responsible for this formula, but they call it Ohm's law. B is equal to current times resistance. So in here we have here, they call it sine wave in the math class, in the classroom, in high school. Call it sine wave. There's a wave up, a wave down. Positive up, and then it returns to its starting position, and then flow alternates, or negative. There's a negative hop here. This is one complete cycle. First hop is positive, the second hop is negative. So they call it sine wave. In our classroom discussion in high school or even in college, maybe they call it alternating current. So the current here is, the symbol is this, alternating current. It flows up, down, back and forth. So the current flows here, up, down, reversing, up, from positive to negative. And now, what is this? This, the equivalent circuit diagram of this lamp alternating current, is this. Resistance, that's the lamp, the resistance here. So, they call it a load. You need to put a load here to produce this closed circuit, just like this one. The resistance here is a resistor. Seems that you're just substituting it to the resistor here, because it has a resistance of 11 kilo ohms. That's the resistance of the bulb. And as I've said, this is equivalent circuit of this one. When you close the switch, current flows here, alternating current, goes back, flows again, goes back, flows again, and 60 Hertz. What is this 60 Hertz here? We got this Hertz formula. What is this Hertz formula? Hertz is also a scientist. In 1 Hertz is equal to 1 cycle per second. So when you see the sine wave, up, down, equivalent to 1 cycle. Here, in order to get 1 Hertz, you need 1 cycle per second. So, when you see the sine wave or this alternating current, we cannot see that, but we can draw that. It takes 1 cycle in 1 second. So, this is 1 Hertz. 1 Hertz or 1 Hertz. 1 cycle flowing into the wire with a time of 1 second. So, in 1 second, and 1 cycle per second, it is 1 Hertz. 1 cycle in 1 second equals 1 Hertz. So this 60 Hertz is equal to 60 cycles per second. So it means the 60 Hertz provided by the electrical company to our house, 60 Hertz is 60 cycles per second. So it means that in 1 second, the sine wave is flowing here back and forth in 60 times. 60 cycles per second. 60 pieces of this in just 1 second is flowing into the lamp very fast. See? 60 cycles per second flowing back and forth. 60 times of this. 60 times of this wave. Very fast. And now, this Hertz is a unit used to know the cycle per second, or is equivalent to cycle per second. They just use Hertz instead of cycle per second. 60 Hertz, 60 cycles per second, 1 Hertz, 1 cycle per second. To short the formula, if you have 1 Hertz, it means you have 1 cycle per second. And since we have 60 cycles per second, is equivalent to 60 Hertz. This is 60 Hertz. And you always see this 60 Hertz, 60 Hertz, 30 Hertz, 20 Hertz. Oh, that is the scientist, Hertz. And because of that, we got this frequency formula. And you know, if you have a cycle per second, they call that frequency. So a frequency is cycle per second. Now, in order to know the unit of the frequency, you need to use this hertz. So frequency is equal to hertz. So this is frequency, 60 hertz, 60 cycle per second. And we need a unit called hertz to know that this is a frequency. So there is a frequency here. The frequency is 60 hertz. Because frequency here is measured in hertz. That is the unit of frequency. Frequency is equal to cycle per second. We now got this formula. So we know that the unit of the frequency is cycle per second is hertz. So that is the frequency here, 60. That is provided by the electrical company. So in here, we get the previous circuit here. This is direct current. Unlike here, alternating current. Here, direct current. It means direct, only flows in one direction. When you close the switch, current flows from this negative positive to the resistor LED and flows back on and on and on as long as there is a voltage supply. Only one direction. DC, direct current. When you draw the DC, I don't have the drawing, some sort like direct current, straight line. But here, this is alternating. There is a positive half cycle, negative half cycle. And they call it this, by the mathematician, a sine wave. So here we're using direct current. So that is the circuit of that one. And why is it 12 volts? Because I use a step-down transformer, not a bumblebee. It's a transformer in the electrical terminology. So this is our previous circuit in comparison with this our new circuit, a lamp circuit, 220 volts. See the difference? See the symbol of AC and the symbol of DC, direct current. It's just like a battery because this battery is a direct current supply. The load here and the load here. See? We need this resistor, protect the LED in direct current source, 12 volts, direct current, DC. Here, we have 220 volts, 60 hertz, and connected to the lamp. So that is very big 20 volts power supply here. So let us see the circuit here. Once I close the switch, current flows here and go back again. Here, Bob, in 1 second, it produces 60 hertz or 60 cycles. It's like here, on 1 hertz, 1 cycle per second. So it in just 1 second, it is producing 1 cycle per second, 1 hertz, 60 hertz, 60 cycles per second in just 1 second. Push the switch. Oh, too much light. See the light here? That is our 220 volts power supply. A bulb, the first bulb invented by this Thomas Edison. And the one, let us see the circuit here. Oh, it's not connected. Let us first connect the power source here. Something wrong. Yes. And now we have this LED circuit. Oh, something wrong again. Oh, that's it. See that? LED circuit and bulb circuit, lamp circuit. We get the two circuits here. A LED circuit and a lamp circuit. And this is the diagram. Let us first kill the light. It's so very it's very light. So we now know the phenomenon called alternating current. If you touch the wire here, you become electrocuted. Why? Because this is 220 volts and the frequency is 60 hertz. In 60 cycle per second, in just 1 second, the sine wave here flowing to your body in just 1 second of 60 times. 60 times, alternating back and forth. Back, forth, positive cycle, first half cycle, negative half cycle, positive, negative, 60 times. 60 times of this 60 hertz with this formula. So that is, they call it 220 volts closed circuit. In this one, I believe this is closed circuit of a direct current source or DC. That is the big difference here. Let's just take again AC alternating. The symbol is this sine wave, up down, and the current flows back and forth. Here direct, only one direction, from positive to negative. And that is the circuit, our previous circuit. And this one, this is our new circuit. It's 220 volt circuit, and this is just 12 volt circuit. Okay, and thank you for watching the video, and bye bye.